Alright, welcome to this screencast on Arduino programming. What we're going to be doing today is we're going to be learning about event-based programming. Now, one of the things that I hate about Arduinos is that they give you this simple program, the little Blink program, and it is written in perhaps the worst way possible. In fact, they also don't give you tools to write better programs. What we're going to do today is to learn to write programs that are event-based, which allow us to have programs that are a lot more flexible, a lot more easy to write, and a lot more intuitive. But to begin with, let me show you what the standard Blinky light program looks like. So in Arduino, what we do is we always say, pin mode, and we'll set pin 5 to be output. Okay, so pretty standard. And then on pin 5, we have wired an LED with a resistor. Okay, so it's just a simple Blinky light program. So what we're going to do is in our loop function, so the setup runs once, and then it's done. That's where you do all of your standard setting your pin modes and whatnot. Then your loop runs over and over and over and over again throughout the life of the Arduino. Now what they usually do for an example program is they give you something like this. They'll say digital write pin 5 high. Okay, so that turns the light on. And then they will use the most evil command in Arduino history, which is delay. Okay, so we'll delay for 1,000 milliseconds, which is 1 second. And then they'll say digital write to our pin 5, and we'll write it low, which will turn off the LED. And then we'll delay for another 1,000 milliseconds. Okay, so the light will go on, then it'll go off. On, wait a second, go off. Wait a second. On, wait a second, off. Wait a second. So it'll do that over and over until you turn off the power. Now the problem with this is, it's fine as far as it goes, but let's say we wanted to add a button to it. Okay, let's say we wanted to add a button where if you push the button, it stops blinking, and if you push the button again, it starts blinking again. The problem is you can't actually do that with this code. There's no easy way to modify what we have here to allow for button pushing or anything else. Because, for example, let's say that I wanted to use pin 2 as my input. Okay, well then you'd say, okay, well we just check to see if pin 2 is high or low. Well, that's good, but where do I do it? Let's say that I do it right here. If digital read 2 is equal to high, then I do something, else I do something else. Okay, well the problem is that since we have this delay loop, while we're running our delays, it can't read our pin. So if I push the button anywhere other than a transition, it's not going to see it because we're doing these delays. And delays just basically say stop doing anything and wait that many milliseconds. Okay, and that's not what we want. What we want is to actually check to see if someone's pushing a button. And so the way that you normally write this on Arduinos is it's actually really awful. I'll do it for you because I love you that much. I'm going to write awful code so you can see how bad it is. So what you need is you need a state variable. So let's say int current state. Okay, and we're going to initialize that to 0 for off. And then we'll say int time spent. And we'll set that to be 0. And then we'll have a last time changed, and we'll set that to 0. Okay. So what we're going to do is rather than delay, we're going to count our delays. Okay. So we're going to say, so we're going to start out. Let's have a variable for is blinking. And let's change this to be called blink state. So is blinking tells me whether or not I should be blinking. And blink state tells me whether the blink is on or off. And the time spent tells me, actually I don't need time spent. I just need the last time we switched. Okay, so what we're going to do on our loop, we're going to say if is blinking, Then we run the code if we're in the blinking mode. Else, we're going to run the code if we're not in the blinking mode, which will probably be nothing. We're not going to do anything if we're not blinking. Okay? And so rather than do a delay, what this is going to do, if we are blinking, we say, so current time equals millis. And this is going to give the number of milliseconds since we started our Arduino and put it in cur time. And actually, this is an unsigned long, but it doesn't matter. You can use an int. It'll just be it just means that if you keep it running for several days, it may fail. So anyway, so we've got a cur time, number of milliseconds, and then we'll say, so we also need to know our delay time. So we'll say delay time, we want it to be 1,000 milliseconds. Okay, so we'll say if cur time is greater than the last time we changed plus delay time, then we will change our state. Else we will do nothing. Okay, so if so this tells us whether or not the current time is 1,000 milliseconds after. So if that's true, then what we'll do is we'll check the blink state. So we've got this blink state variable up here. And so we'll say if blink state is equal to 0, then we'll set blink state to 1, and we'll turn on our LED. Digital write to our LED pin and set it to high. And then we'll say last time changed equals cur time. Now remember, this is the way to write it that's hard. So if you're having trouble following it, that's because this is hard to read. Okay? So if the blink state is 1 instead, then we're going to change it back to 0. Blink state equals 0, digital write 5 low, last time changed equals cur time. Okay, so now, what's happening here is rather than doing a delay, we're simply checking every time through the loop whether or not it's time to change the light. Okay, and by doing that, it means it's going to run our loop over and over and over again and allow us to also check to see what the button's doing. Okay, so here is the end of our code for the blinky light. Okay, so this is our blinky light code. So at the end of this, we're going to write our code for checking the pin. So if digital read 2 is equal to high, if someone pushed the button, then we will set is blinking equals 0. Okay, and so that will turn off our blinky. Whatever blink state it's in, it will turn off. Okay, now, and actually what it needs to do is check to see what the blink state is. If is blinking is equal to 0, if it's off, we'll turn it on. Else is blinking is 0. So if it's off, we'll turn it on. If it's on, we'll turn it off. Okay. So the reason why this works somewhat, we'll see other problems in a minute. The reason why this works and the other one doesn't is because this one will, so every time through the loop, there's no delay here. There's just this checks to see if we've waited enough time. Okay, it doesn't actually do the delay. It just sees have we run through the loop enough times for this time to have changed. Okay, and so every time through the loop, it can also check the pin state. So rather than having a resolution of having to wait 1 or 2 seconds to read the pin, this does it in less than a millisecond. So anyway, the problem is, so we'll go ahead and upload this. Okay, as you can see on the board, I've got more things installed here than just our single LED, but the pins and LEDs are set up. This is for a more complicated program we'll get to at the end. But you see, when I turn this on, if I push the button, now notice it just stayed on. It didn't actually start blinking. And we'll get to why in a minute. about half the time, there we go, now it's blinking. So this button is not actually working very well. And the reason for that is that the way the code is written, if we go back to the code, so let's look up here at the digital read function. Okay, so what happens is that this is switching the state, but it's not like if this is running every time through the loop. So if I push that button down, then it's going to if I push the button down, it's gonna read high here. Okay, so it's gonna set is blinking to 0 or 1. But the problem is that while my finger is still on the button, it's gonna run through this loop again, and it's gonna check and it's gonna switch it again, and it's gonna keep on switching that maybe thousands or hundreds or thousands of times until I let my finger up. Okay, and so only then is it going to start. Is it going to figure out which state it's in? So basically, whichever state it lands in is going to be kind of random because it's based on what exact microsecond I let up on my finger. So even this, with all this code, we need more. We need some code to tell us, did we push the button? Have we already pushed the button? Okay, so we'll do int was button pushed, and we'll start it at 0. And so if it's high, okay, so first we'll check if was button pushed. So if we've already been pushed, then we'll check and see if it's low. So we'll wait until this button is low, and then we'll set was button pushed back to 0. Otherwise, we'll do all this stuff. And then here, once we find out that it's high, we'll say was button pushed equals 1. Okay, so now we'll upload that. Let's try it out. So that stopped it. So pushing it starts it. Pushing it again stops it. So that actually works. Now it's actually not perfectly good because there's a thing called debouncing. Sometimes when you push a button, it doesn't push directly. It kind of the signal wobbles a little bit until the button goes all the way down. Now I haven't had quite so much trouble with these buttons, but it can happen. And so what you sometimes need is to put a debouncer in your code to check to see not only did you push the button, but you give it a little bit of a delay to make sure you really pushed it, and then when you let go, make sure you really unpushed it. So in addition to all this code, you need additional debounce code. Now you actually can put the debouncer in hardware, but we generally try to put our stuff in software because it's a lot cheaper. All right, so this is the problem, is that we wind up with code that looks like this just to do a little blink. All right, and this is totally, if you didn't know what was going on, this is almost unreadable. Okay, so what I did is I built a library called Eventually, and that's our event-driven library. Okay, so we'll open up a new sketch, and we will include the Eventually library. Okay, and so on our setup, so we'll have our same pins, pin mode 5 for output, pin mode 2 for input, okay? But what we're also going to do, we're going to scrap our loop because Eventually has its own loop. Let's save this. In addition to our pin setup, we also need to declare an event manager. Okay, so EVT manager, MGR. So this is the name of our event manager. And then instead of our loop, we'll give this command from the eventually library called use eventually loop and give it the manager. Okay, and this will compile. Doesn't do anything yet, so it's not exciting. And so what this does, this replaces our standard Arduino loop with the loop from the eventually library. So now, so this sets it up. So now we need to do something. All right. So what we'll do is we will break our program up into functions. Okay. Now, these functions from these actions in eventually all return type bool. Okay. So rather than void, they return bool. And so what we want to do is for every event that happens, we want to have a function. So for example, we'll have a function for blinking the light. So we'll say bool blink light. Okay. So what this function will do is we'll set an integer blink state, and this will just say if blink state is equal to 0, then we'll switch it to 1, and we'll write the pin. Digital write 5 high, else blink state equals 0, digital write 5 low. So this blink light is just, all it does is handle flipping the light on and off. Okay? So the way that we incorporate that to our program, so before we add our button pushing, let's just show that working. So what we're going to do is we're going to add a listener to our event manager. So we're going to do manager.add_listener, and we're going to create a new time listener. And so time listeners, the first parameter they get is the delay. The second parameter they get is whether they shoot one time or if they beep every 1,000 milliseconds. And so we'll set true to beep every 1,000 milliseconds. And then the last one is the function that we want to call. And so first we have to declare that it's a function. It's an action for this. So it's EVT action in parentheses, and then blink light. Okay, and so note this does not have our open close parentheses like this because we're not calling the function. We're passing in the function as the action we want to do. Okay, so then let's see here. New EVT. So that's the end of add listener, semicolon. Let's stretch this out a little bit. There we go. So this is what our line looks like. And so what this does is it simply adds a listener that listens to time, and every 1,000 milliseconds it will call this function. Okay. So let's upload this and see what this does. So that is our LED blinking from our blink program. Okay. So now we'll go back and check out and see how we can add the button push into that. So what we're going to do is, so now what we need is, here we have a listener for blinking the light. What we need is a second listener for a button push. Okay. So we will add a function. Oh, one thing I forgot, which it doesn't really matter here. I need to return false from my blink function. So here, I need to have a function to say stop blink. And this will stop the blinking. So what I'm going to do to stop the blinking is I'm going to reset my context, and that's going to go and erase all of the listeners that I have active. And then I'm going to add a new listener, and that's going to be a pin listener, and it's going to listen on pin 2, and it's going to call the action start blink. Okay. And in order to register this, we need to register this with our manager at the start. Add listener, new EVT pin listener to stop blink. All right. So now we just need the start blink function, which interestingly will just do these two things again. So this needs to return true, and the reason these return true and false, returning true stops the event cycle, so it doesn't run any more events on that cycle through. Returning false says keep on checking. So it doesn't have, for simple programs like this, it doesn't matter too much whether you return true or false, but for more complicated programs it does. So this will be start blink, and this will just be, it's going to reset the context, and then it's going to do this again. It's going to add these two listeners back. And then here we're going to return true. Okay. So now we will upload this. So here is our Blinky light program, and so I'm going to push the button, and now it stopped blinking. And when I push the button again, it's going to start blinking. So as you can see, using these listeners is a lot easier. In fact, we can make this program even simpler by, instead of adding these listeners here, we can erase these, because this is just start blink. So we'll just call start blink, and that will get rid of 2 lines of code. So what I'm going to do on my setup is I'm going to set up these pins, and then I'm going to start blinking. And all that's going to do is add listeners. It's going to add a time listener to blink the light, and a pin listener on pin 2 to stop the light. And this pin listener will do all the things that I talked about last time. It'll debounce the pin. It will make sure that it started from the opposite state. It'll do all those sorts of things automatically for me, so I don't have to worry about that. And I can set those. I can put settings on those manually if I want to. And so when I start the blink, it adds this time listener. So every 1,000 milliseconds, it now calls the blink light, and blink light simply checks which state it's in and will blink the light as appropriate. So that's event-driven programming. As you can see, sometimes it results in longer code by a little bit, especially for these shorter programs, but it's a lot less complicated. It's a lot easier to follow. So if I go back to my previous program, you can see that I had a whole lot of variables that I had to keep track of. And this is just for one button push. And then I had this nasty, nasty loop I had to go through just to get it to work in just very basic functionality. So if you imagine if you had 4 buttons and they all did different things, and you had to be debouncing and checking their state all the time, this code would be unreadable. So by using an event library like Eventually, then you can simplify your code so that you're simply stating what you want. You want to add a listener to time, I want to add a listener to a pin, and then this is what I want to do. Okay, and so you can do a lot of complicated stuff. For instance, I have a tennis program here that uses Eventually, and I'm not, the code for this is in the Eventually examples, so I'm just going to upload it and show it to you. So what this does is you push a button and it hits the ball over to the other side, and if they miss it, then it'll blink at them. So I can't do it with one hand. Maybe I can, maybe with my other hand. So hit, miss, and it blinks at you. So that's the tennis program, and that's done with Eventually, and you can find that in the examples. And it's actually fairly straightforward when you use an event library. Okay, so you can get the Eventually library either through the Arduino library manager, or if you don't have the library manager installed, or for some reason you can't find it, you can just go to my GitHub account, which is github.com/Arduino /Johnny B. And this, let's see here, it is under, go to repositories, and you have the eventually library. You can then download under releases. You can click on the release you want. You can download it as a zip file, and then you can add it to your Arduino. You go to Sketch, Include Library, Add Zip Library. Then you find your the zip library you just downloaded, and that'll add it to your both to your project and to your list of libraries. So that's a quick example, a quick tutorial on how to use the eventually library. I suggest that you grab it and take a look at the examples. They'll help you out a lot. Hopefully that will get you started in event-driven programming with Arduino.